Very quick notes to help you do the packet. Just going over some rules about triangles. A lot of them we've covered in the past, so they'll be, just reviewing. You'll have to copy them down. There is no guided notes this time, so you just have to copy them on a clean sheet of paper. They're not real long. Ways to classify triangles. Remember, if we're classifying a triangle according to its sides, scalene triangle is a triangle with no sides congruent. Isosceles triangle is a triangle that has at least two sides congruent. And then an equilateral triangle has three sides congruent. If I go too fast, ignore that. If I go too fast and turn the slide too quick, just stop the video. So write those down. We've written them down a couple times already this year. Remember, with an acute triangle, so those are three ways according to the sides. So based on what the sides are in the triangle. If we're naming the triangle according to its angles, or based on what angles it has, then an acute triangle, all three angles have to be acute angles. An obtuse triangle has one obtuse angle, not three obtuse angles. The triangle can't have three obtuse angles. It can only have one obtuse angle. A right triangle, remember, has to have one right angle, exactly one right angle. And an equiangular triangle, all three angles are congruent, and we're going to talk a little more about it later on the slideshow here. So all three angles are the same. If a triangle is equilateral, draw this on your notes there. If it is equilateral, then it's also equiangular. So it has to be both. If it's one, it has to be the other. So if I tell you a triangle is equilateral, not only are all three sides congruent, but all three angles are also congruent. And then this last thing down here, if it's an equiangular triangle, then we know, if that's equiangular, then we know every angle is 60 degrees. And that comes from one of the next rules that we're going to cover about a triangle that you should already know. That's this one right here. Three angles of a triangle must add up to 180. On this slide, all I really want you to write down on this slide, these first two. And don't worry about the theorem part. That doesn't matter. You can just write that this is a theorem and this is a theorem. The number doesn't make any difference. So the first one here, three angles of a triangle always add up to 180, no matter what they are. If I give you some triangle and I tell you this angle's 50, this angle's 70 degrees, you should be able to find this missing angle by adding those two up. So 50 plus 70, that's 120. Then subtract that from 180. Three angles of a triangle must add up to be 180 degrees. So that missing angle there would be 60 degrees. The next one, this is new. One of the few new things on this set of notes. The measure of an exterior angle of a triangle equals the sum of the two non-adjacent interior angles, or remote interior angles, another way to name those two angles there. So the measure of an exterior angle of a triangle equals the sum of the two non-adjacent interior angles. Again, if I go too fast, because I'm going to switch back to draw a picture here because there's not room on this slide, just stop the video so you can write down those two things. Again, these two, don't worry about these bottom two so much right now. This bottom one we actually just talked about. Triangle can only have one right angle or one obtuse angle. It can't have more than one. And the other one's just sort of a common sense one. So on that exterior angle theorem, if I have a triangle, this is my triangle. To draw an exterior angle, we'll call this angle 1, this angle 2, this angle 3. to draw an exterior angle of a triangle, all you do is you take one of the sides of the triangle and you extend it straight out. So if I wanted to draw an exterior angle, let's say at angle 2 right here, I might extend that side straight out. So that angle 4 is called an exterior angle. And that exterior angle and the interior angle that's adjacent to it or hooked to it should add up to 180 degrees. That's what they're going to be supplementary. Now what the theorem says is that this exterior angle has to equal the two non-adjacent interior angles. Non-adjacent means not hooked to, added together. So non-adjacent, the angles that aren't hooked to angle 4, the interior angles that aren't hooked to angle 4 are 1 and 3. So angle 1 plus angle 3 has to equal whatever angle 4 is. If I draw another picture, and maybe I make the exterior angle right here. Angle 5, there's an exterior angle. We'll call this angle 6, angle 7, angle 8. Angle 5 and 8 have to add up to 180, but angle 6 plus angle 7, those two added together, will always equal that exterior angle. So the two angles in the triangle that are away from the exterior angle add up to equal that exterior angle. Next thing on this, main thing here, just draw that picture and we're going to talk about it. So just draw the picture and label it with all that stuff. An isosceles triangle. If I draw an isosceles triangle, if I tell you a triangle is isosceles, first thing you're going to know is it always has two congruent sides, and those two congruent sides are called legs. The third side, that's not one of the two congruent sides, is called the base. The base does not always have to be on the bottom. I drew it so it was on the bottom this time, but it doesn't always have to be there. So you have two legs and a base. The angles. The angle that's between the two legs is always called the vertex angle. Very important that you know that. That's how they'll name isosceles triangles a lot of times, is they'll say a triangle ABC is isosceles with vertex angle A. So that'll tell you where everything else is located in the isosceles triangle. So this angle between the two legs is called the vertex angle. The other two angles that are down here and they surround the base are called base angles. Real difficult. They're called base angles. So those two angles are called base angles. In an isosceles triangle, we always know that the base angles have to be congruent. So you have the vertex angle, you have the two base angles, and the base angles have to be congruent, the legs have to be congruent, and then you have the base. Isosceles triangle. We had these a while back. So in an isosceles triangle, and I'm going to draw this picture out here. In an isosceles triangle, you have the two legs. The angles across from the two legs always have to be congruent. Those are the base angles. So across from the two legs, those angles have to be congruent to each other. And it works, the converse of that, or vice versa, also works. If you know these two angles are congruent, then you know the sides across from them are congruent. So you might want to draw this picture. Always works that way. If two sides of the triangle are congruent, the angles across from them are congruent, and vice versa. And the last one, an equilateral triangle. On this, copy this down. Copy the whole thing this time. Again, you don't need the fact. A corollary, again, is just like a postulate, something that we just take for granted is true. The first corollary says, if a triangle is equilateral, then it also has to be equiangular. And the second one says, if it's equiangular, it has to be equilateral. I said that on the first slide. In an equilateral triangle, you know all this information. All the sides are congruent. You also know all the angles are congruent. And not only do we know all the angles are congruent, but since the three angles of a triangle have to add up to 180, the only way mathematically it works out is that each angle has to be 60 degrees. And again, you can stop the video here if you didn't get it all copied down. There's 60 right here. Oops. 60 degrees in that blank. And that's all of it. What I want you to do the packet. It's laying up on the table where normally you pick up your notes. Deals with all this stuff. A lot with triangles.